So this is Aaron Roth. I'm still Liz Bradley. And what we're going to do, and this is a panel, it's a discussion, it's not us yakking at you, or a little bit of that first. But what I'm going to do is talk a little bit about the CCC's efforts in privacy and fairness. And then Aaron will talk a bit about what he thinks is really important about this field, and then we'll take some questions. So as you saw in Beth's presentation, the CCC's interest in and contribution to privacy and fairness goes way back. I first got involved with this when we were, and this is a little bit of a window into how the CCC works, we spent most of the spring and summer of 2016 preparing what are called transition papers, white papers, to be offered to the incoming presidential transition team to perhaps educate that transition team about what the research community thought was important. This was 2016. That we had to, I think that was where I learned the word pivot, when the incoming presidential administration was not interested in hearing about these things. But anyway, so that's one of the things that the CCC does, is come up with these white papers. Some of them are prepared for education of policymakers, which is really kind of fun. This is a paper called Big Data, Data Science, and Civil Rights. So that's how I got involved. After that, the CCC formed a task force, which was at the time 3 people. So we have this group of 20-some people. We form off into little groups, each of which is interested in a thing, because you can't get anything done with 20 people. So you get something done with 3 people. And you think together and come up with, for example, a workshop. Now, our workshops, and Beth alluded to these are one of the ways that we catalyze research. They come, we say, top down, bottom up, and sideways. So top down, someone from the NSF says, we would like you to think about X. And we go away and we think about X for a while. Which is the top down and the bottom up? I can't remember. There's 3 of them. Either the NSF is top down, bottom up is from you guys, and then sideways is from the council. Okay, so the council will think about, we should have a workshop on why. But we also have an open call for proposals for visioning workshops that goes out often in December, I'm not sure. And these are very lightweight things, 3 or 4 pages, a couple of organizers, who you're going to invite, what you're going to think about. And then the CCC, fabulous CCC staff, will get everybody together and run it all for you in a beautiful hotel, wherever you want. So this is something to think about, maybe not right now, okay, but as you maybe have some ideas from this symposium and you talk to each other about it, go back, talk to your friends, there is this mechanism for galvanizing effort around such a thing. So the workshop that I'm talking about, that this task force put together, was run by Alexandra Chudakova and Aaron Roth. It was on fair representations in fair and active learning. It was in Philadelphia in March, and out of that came a what will probably become a CACM paper about this. There will also be blog posts, there will be slide decks. I'm not scaring you, Aaron, but there will be things that, these don't just kind of happen and then die. The CCC helps you leverage your thinking and your work on these events. The CCC will, Beth will take your slide deck to, a congressional staffer. And so these are ways to leverage your effort and your impact in terms of, maybe you'll create a whole new funding initiative at the NSF. Maybe you will educate the public, or perhaps more important, a policymaker, about the impact of your idea. And certainly make new research collaborations. That's really the goal. Anyway, so that's a little bit about the kind of a mixture of how some of the CCC's activities work, and specific instance of that in the area that we're going to talk about, which is privacy and fairness. And again, that workshop that we had, I helped just a bit, that Aaron and Alex ran in March, had some really interesting outcomes. So fire away.
All right, thanks. And maybe I'll start by just recommending these workshops if you guys want to propose to run one of them, because the CCC really does make it very easy, and they're great. So so I didn't come prepared to say anything in particular to you guys, because I was told this was a panel. But let me maybe just start by giving a little bit of background on, like what are these problems of fairness and privacy and algorithm design, who are we as computer scientists to think about social issues, and why I think it's sort of a really exciting opportunity for, early career researchers. So the background, and I'm sure you have all heard a lot about this in, just popular media accounts, is that, machine learning is sort of an old thing, and, we've been using it to filter spam messages for a long time. But what's sort of new in the last decade, maybe, is that we're using machine learning, one, for, like making really important decisions about particular people's lives, like whether they go to jail or not, or whether they get loans or not, whether they're hired, things like this. And two, we're training, these algorithms on really sensitive personal data, things like medical and financial records. So sort of unavoidably, even if we want to be, technocrats in our ivory towers, the act of designing and deploying algorithms for these tasks is bringing us face to face with what you might normally think of as social or ethical issues like privacy and fairness. And those are the two that, this panel is about, but those aren't the only ones. Okay, so it's sort of unavoidable, and you might say, like, okay, as computer scientists, maybe we created the disease, now we get to find the cure. First of all, like, why us? Moral philosophers and legal scholars have been thinking about privacy and fairness way longer than computer scientists have, and I think the answer to this is, part, computer science as an imperialist field, who better than us to think about any problem. But by the way, I say that not entirely sarcastically. I think this is sort of a feeling that computer science as a field has, that not all fields do, and I think it's healthy. But part, it's also an issue of necessity. I mean, these decisions are now being made algorithmically at a speed and scale that, just it's not feasible to have sort of human regulatory oversight. And so, we're not able to sort of put the horse back in the barn there, and we shouldn't want to. Of course, algorithms are, like making all of these processes more efficient and better in various ways. And so ultimately, if we want that our decision making should satisfy various kinds of social norms, we have to be precise about what that means, and we've got to embed those into the algorithm. So that's what we're good at. So, okay, so that's sort of the backstory. Okay, and then so like, what are we supposed to study as computer scientists in these areas? So first, I would say that, there's nothing new under the sun. Like everything else in computer science, studying privacy and fairness and algorithm design, it's about understanding trade-offs. That's what we do, we understand trade-offs. And we're really good at understanding trade-offs between things like computation and memory and, predictive accuracy and data requirements. And now we just have a couple of new things that we need to also trade off with all of these desiderata, privacy and fairness. But, like a big part of that problem before you can study these things precisely is to quantify exactly what those things mean. And we can, of course, and should, like, interact with our colleagues at the, the philosophy department and then the law school. But I think we will find that, we're not just going to find the answers there. Like, we're not going to just, walk over to the philosophy department and figure out, like, this is what fairness means. Not because, they haven't been thinking about these things carefully for a long time, but just because, these academic traditions are used to working with the ambiguity of natural language, and although they've got interesting things to say about the words privacy and fairness in different contexts, they can't tell us, how we should design our algorithms to satisfy these things. So part of the research problem, and this is sort of the job, of us, in this room, is to, in part, just figure out what exactly these things mean. And so here, I think, privacy is on a very different footing than fairness, in part because the technical community has been studying privacy already for about 2 decades now. And maybe after about the first decade, a large part of the research community started agreeing that at least for, a large collection of statistical data analysis tasks, there is sort of a right definition for what privacy should mean, and it's differential privacy. And so I think of this as sort of a success story and what sort of our study of fairness and transparency and these other things might aspire to. So for about a decade, differential privacy was something that was a curiosity, a mathematical curiosity amongst, like theoretical computer scientists. We'd write papers about it. We'd have little workshops and talk to each other. But in the last few years, we've seen sort of rapid and widespread deployment of these ideas that we were thinking of, telling each other about a decade ago, both at like tech companies like Google and Apple and in the US government. So the 2020 census is going to release its demographic information subject to differential privacy protections. And that was fun. I had the sort of privilege of sort of being around at the beginning of that when nobody knew what they were doing. And now we know a little bit more about what we're doing, but I think that if you want to study fairness, the time is now, right? Nobody knows what fairness means. There's basically as many definitions as there are papers on the topic. That makes the field exciting because it means that you can have, simple ideas, simple in hindsight, that have dramatic effect on the field, on how thinking in this area progresses. Which is something that's sort of harder to come by when you have a more mature field with, like long-standing open problems. There are no long-standing open problems in fairness research. You get to come up with the problems, which I think is more fun. And so, like even though we don't really know what these words mean yet, there's already the opportunity for serious research. You can pick a definition, you can take it seriously, and you can try to derive its consequences. How must satisfying whatever you mean by fairness trade off against, for example, predictive accuracy in a machine learning application? And what our job is as computer scientists, as technical researchers, is to map out what these trade-offs are. We'll find that there are Pareto curves because nothing comes for free. And our job is not necessarily to figure out where on these trade-off curves our society should operate, but our job is to understand what these trade-off curves look like so that stakeholders and policymakers can make informed decisions. All right, so that's my spiel.
So we're happy to open it up for questions. I have prepared a few provocative ones if no one has any. Yep. Remember the name and affiliation, please.
I don't remember that. Hi, my name is Pamela Wisniewski. I'm from the University of Central Florida. And just to preface this, my question is coming from the standpoint of a human-computer interaction researcher from the networked privacy community. And my question is that when you are talking about privacy and fairness in computing, the underlying assumption is that we are applying that specifically to algorithms, which, being in HCI, I present my work to my CS colleagues, and they ask me where my algorithms are. So I get it. But when you're talking about the visioning and the scope of privacy and fairness, can that also include a broader conceptualization? For instance, privacy in the terms of sharing data sets between industry and academia in a responsible way, or fairness in terms of making sure that those collaborations are fair, and that the way that we think about who's kept in the know or outside, and the more of the interpersonal boundary regulation of the term of privacy, thinking of fairness in those respects instead of like algorithmic fairness. And so when submitting a workshop, could we potentially vision in some of those directions that might be more of the conceptual and not theoretical, but not like the algorithmic?
I'll let Aaron answer the technical end of that, and then I'll talk about the workshop.
Sure. So I mean, okay, I forget exactly how it was phrased, but let me say absolutely. So by the way, like as a computer science imperialist, think that, human decision making should also be thought of as algorithmic. We just don't, have precise specifications of the algorithms. But, when I say algorithmic fairness, I don't mean that you have to have, 15 lines of code that you're studying. Fairness issues arise whenever there are decision-making processes, and those decisions can absolutely, and in fact usually are, made by human beings. And what the research on these topics has to say definitely applies to that just as well as, when you're using logistic regression or something to make a decision. Data sharing, of course, also is a main sort of topic of study in the privacy community. And there, I think, even when we're talking about, as we often are, data sharing between, organizations and human researchers, algorithms, as we traditionally think of them, play a more central role, because the question is, the researchers, who are gathering the data and who ultimately want to make use of the data may have, little interest in, studying, algorithms for privacy protections. But the task of coming up with a, useful summary of the data that nevertheless is, not disclosive about people's private data, that's an algorithmic question, and you can think precisely about how to design algorithms that will, be useful to the researcher downstream and that will offer rigorous protections to the individuals in the data set.
And in regard to workshops, in the past 3 or 4 years, and Anne can correct me on this if I'm wrong, I've seen an awful lot of visioning proposals come bubbling up organically out of the community at the boundary of computational science and social science. It's been a ton of that. And we're very receptive to that. We understand that this is all situated in an important context of, not silicon, just silicon. That when we get a visioning proposal, it's not like the NSF where there's a panel and it's up or down. A few of us will look at it and offer suggestions, and then there'll be an iteration, then maybe 2, and then it comes in final form and we circulate it to the whole council, and everybody gives suggestions. It's not that there are opportunities to reject, there are opportunities to make it better, and almost all of them eventually get improved to the point where we fund them. So we're happy, and contact us early if you're thinking about such a thing, even before you have a proposal, just a paragraph, and we can help you say, we won't say yay or nay, we'll say how about this with some help. Yep. Other question? Lev from?
Oh, Lev Raisin from University of Illinois Chicago.
Thank you, sorry.
So another way in which privacy and fairness seem to differ to me is that, well, let's start with fairness being a loaded term in some ways, where privacy, I think, we can all agree on a definition because we somehow all can maybe think of differential privacy as being reasonable. And you can get basically people of any party and any administration to somehow agree that leaking data seems not private. Whereas fairness, I mean, I look at all the definitions of fairness, and some seem fair to me, and some seem outrageous to me, and then if you take other people with different political inclinations, they will have different views of it, or not even political inclination. And so somehow I am very skeptical of us being able to come up with a definition of fairness that's as successful and easy to study as we have for a definition of privacy. And I could imagine us coming up with a Pareto curve of a lot of definitions and their consequences, but having all this be used is very hard for me to imagine. And I wonder if there's a way to somehow depoliticize the term or the research. And maybe because I think somehow academics are often homogeneous in their political views, I think it's very easy for the academic community to go off on its own thing and think they're doing great things and bring back things that nobody will ever use. So somehow, I don't know. So, I mean, maybe there are a lot of questions in there, but I hope I'm sure you've thought about these issues. I know you have, but I don't know what answers there are.
Yeah, so let me start with maybe the less dangerous question, the first one. So yeah, totally. I mean, like, it's too early to see. You know, you're right that in hindsight, we were sort of lucky when studying privacy that we, again, for not everything the word means doesn't cover why you're wearing pants, for example, that at least for statistical disclosure, we've agreed on some definition. And we're definitely not there with fairness, and it might be the case that for whatever reason, that's not possible, and we end up with sort of lots of different things. But let me also just point out that with privacy, we have the benefit of hindsight, and there was a decade of research with, again, dozens of definitions before differential privacy was proposed. And, coming up with the definition of differential privacy was the result of thinking carefully for a long time, and has, I think, sort of non-trivial, philosophical insight in the sense that, ultimately what the definition can promise is to protect your secrets, but not secrets about you, which is a distinction that if you didn't think for a long time about these things precisely, you might, not have been clear. And for those of you who don't know what the definition of differential privacy is, probably still isn't clear. So it's a common sentiment that, especially because of, early impossibility results, that, there are different things you might mean by fairness are mutually incompatible with one another. It's a common sentiment that maybe, what's going to happen in fairness is, you've got to pick and choose, and we should stop using the word fairness. There's different kinds of fairness, and they're in conflict with one another. But it's only been a few years where people have been thinking seriously about these things. So I wouldn't rule out that, after, as a community, we've thought about these things for another decade, we find that, there's some underlying principle that we can all get behind. As to whether, we're just all a bunch of, liberal Democrat shills coming up with our socialist definitions. I think it's not, obviously there is some political heterogeneity or homogeneity in our community, but I think that if you look at, the different kinds of things that people are proposing, you will find technical definitions that, you can get behind no matter what your political background. It's just, you might disagree on which are the right definitions.
So just riffing off Lev's question, where we go off and we do our own thing, and then we come back and with this shiny new toy and nobody wants to play with it. Who should we work with when we're doing this work, Aaron, and how? And these are not the kinds of people that we normally work with.
Yeah.
That goes to your point as well.
It's a good question, and I think there's lots of them, and we haven't yet, as a community, successfully worked with all of them. So at Penn, we've been talking to folks in the law school, we've been talking to folks in the criminology department. Philosophy is another area where there's sort of a long history of scholarship on these topics. Statisticians have been thinking about these things, economists. Figuring out how to work well together, I think, is a challenge. For anyone who's sort of done serious interdisciplinary research before, it's hard because there are real language barriers, not just in the words we use to describe things, but in sort of our worldviews and the things that we take for granted. And it's a challenge overcoming those. So, it's something that we have to do more of.
Can you give an example of, without naming names, of one of these barriers and how you overcame them?
I don't know if we've ever overcome them.
Or how you have attempted to overcome them.
Yes. So okay. So I don't know to the extent that any of them have been overcome in fairness, but sort of in privacy, which has a longer history. I just got back from the Simons Institute at Berkeley, where we had a workshop, and we invited a dozen statisticians and a dozen computer scientists, and we listened to each other's talks. And this wasn't the first time we've done this. We've been doing this, every few years for the last decade, and we're getting a little bit closer to understanding what they're saying in their talks, and I'm hoping, they're starting to understand what we're saying in ours. And, there are now papers about, performing sort of classical statistical inference with differential privacy that appear in our venues, and there are sort of real differential privacy papers in the Annals of Statistics, JASA, but even there, where we've been working on it for a decade, it's slow going.
Mm-hmm. Other questions? How do you think we should inject, well, fairness into our computer science culture? Should this be, I know there's FATML and things like that. What's the right way to do this, and should we be doing this in education?
So I think there's two things here, two ways we can try to embed it in our education. I guess I'm a professional educator. So there's two things. There are, it's important to understand how, when you're, working as a software engineer somewhere and making what seem like, maybe an inconsequential, tweaks to an algorithm, you can actually have, these sort of small changes can have unintuitive and sort of hard to predict but important consequences on people's lives in ways that you might not expect. So it's good to we need to educate people to understand the kinds of things that can go wrong. I think this is something best done by example. We now have sort of lots of case studies of this, and this is something that I think can and should be embedded in like standard undergraduate machine learning courses, for example. Where does what are the pitfalls and traps, frictions to fairness that you might not have thought about. But there's also a technical, mathematical discipline for how to design algorithms that protect privacy and protect fairness, and you can teach courses on these topics, as standalone graduate or undergraduate classes. I've done that. Now these are things that are meaty topics, are probably not going to be a sort of part of the core curriculum in any computer science class. But I think we need to do both, and that the kind of thing we might aspire to educate all undergraduate computer scientists about are just the fact that the fact that algorithms have no moral opinions on their own doesn't mean that they might not result in unintended consequences that we view as unfair, and the realization to look out for that. And then for people who are interested in thinking about these things more deeply, elective classes that can.
Right. Yeah. So Barbara Gross at Harvard has something she calls embedded ethics, and she argues that this should be in every single class in the computer science curriculum. And she works with students from philosophy and pays them, which I guess philosophy students don't often get paid, to kind of co-teach and bring in these kinds of issues in a small way, in a case study way, in every single class at Harvard. And she's working on that. I think that's a good idea.
Yeah, it's a great idea.
One of the things that Barbara talks about is educating students on the issue of, I'm a software developer, I've just gotten out of Harvard or Penn, and I'm now working at large company number X, and my boss asks me to do something that is going to impact fairness of the result. How do I push back on my boss?
Yeah.
Do you have any ideas on that?
I guess you've got to be brave.
Mm-hmm.
I mean, in some sense, I think it's maybe unfair to expect, someone who's just gotten their first job as a software engineer to really push back too hard on their boss. But of course, when we're talking about, incarcerating people and deploying police officers, there might be good moral reasons to do so. Hey, I don't know how you're supposed to do that as the sort of man or woman on the spot there, but as a community, I think we can help in that, for that software engineer who wants to push back, it's going to be a lot easier for them to push back if there are sort of, broadly accessible resources and well-publicized incidents in which, people making similar decisions have led to well-documented bad outcomes, especially if those if those well-publicized bad outcomes led to negative effects on, the boss of whoever was designing the sort of
Yes.
system in question, right? So I mean, there have been some of these, and again, I'm going to mostly talk about privacy because there's a longer history here. But, when AOL released a supposedly anonymized version of their search logs, the director of AOL research was fired. The New York Times wrote an article in which they tracked down some of the supposedly anonymous users in the AOL database and interviewed them for a front-page New York Times article, and they weren't happy. But hey, the new director of AOL research who replaced the guy who was fired isn't going to do that again. When Netflix made a big privacy mistake again and releasing a data set supposedly anonymized by only heuristic means, and it was re-identified, there was a lawsuit. So to the extent that we can understand when people are doing things that are dangerous and document that, and especially if there are, documented consequences, then I think it's, to the extent that we can sort of, make stories like that broadly known, it's going to be much easier to push back against potential new instances of this because, even if your boss doesn't buy the moral case, you can try to explain to them that it's not going to be good for your company in the long run to be seen as doing things that are damaging to privacy or fairness.
And I guess a harder question is, how do we educate the policymakers about this? What do you want a congressional staffer to know about this?
Yeah, it's a good question. I guess that's the CCC's job.
Well, we can tell them. You have to
tell
them. Yeah, right.
So it's always tricky. Again, going back to privacy, one of the big stumbling blocks to sort of getting sort of good privacy technologies like differential privacy embedded in government has been the existence of well-intentioned but ultimately misguided legislation. So for medical records, there's a law called HIPAA which governs what you can do with them, but it mandates sort of the wrong things. It sort of says, okay, there are these 14 identifying attributes, things like name and zip code, that if you remove them, you can then publish your data set.
And that doesn't work.
It doesn't work in two ways. I mean, one, it doesn't guarantee privacy. We know how to re-identify individuals from anonymized data sets like that. But also it really hinders the use of this data. You're removing useful information. Now, this was a law written by smart and well-intentioned people, but it was written, maybe 15 years ago before we really understood the science. And the one problem is laws are sticky. So now that we understand the science, it's a little bit hard to do the right thing. But part of the reason why, as I understand it, the census was able to sort of adopt differential privacy was because although the census is sort of mandated to release its statistics subject to privacy protections, the appropriate legislation there doesn't specify what that means, and so the census was able to hire just well-qualified people who were able to look at the literature and do the right thing.
Right. Yeah.
So I'd be, so we should be talking to congressional staffers, but especially for fairness, where we really don't understand what's going on yet, I would be really hesitant to suggest to them that they should be writing specific legislation.
Yeah. I don't want to be asking all the questions here. Please.
Leon Shah from RPI. So I have two questions, and high-level question about fairness and technical question about privacy. So
Lemma 3 of your last paper.
So about fairness, it's actually related to Lev's question, which is, what would you think be the kind of the holy grail in this line of research? So I'm asking because I'm mostly working in social choice. So there we have many fairness measures, like everything possible is there and give us advice. sorry, it's a technical question.
Yeah.
Anyway, so I've heard many comments and complaints that there are already so many fairness, even though it's a different kind of fairness measures, those are about procedural fairness, but people still think there's really just too many of them. And people are really tired of seeing many trade-offs, like impossibility results. And people don't really have agreement on which fairness criteria is really better or desirable than the others.
Mm-hmm.
So yeah, I guess my question is like in addition to finding characterizing spiritual frontier, which I would think could be very exciting in the next 5 years, but even like if you think about the next 10 years, should I advise my PhD students step into this field, and what would be the kind of the big problem they should be looking at?
Yeah. So I mean, obviously, different people will have different opinions, but here's my view of sort of, in the definitional space, what the most interesting question is. So I'd say that at a high level, when you look at all of these, dozens of definitions that people come up with, there's like a top decision branch. They cluster into two kinds. There are what I would call, statistical definitions of fairness that tend to say, okay, we've got different kinds of people, orange people and green people, and we've got some, pick your favorite, statistical measure that I might put on a classifier. I could look at the false positive rate. I could look at, its positive predictive value. Pick whatever you like that people have. And then I'll just say I want these sort of average statistical measures to be equal across these different groups, or approximately equal. Okay, so that's one family of definitions. There's another family of definitions that says, forget statistics. Fairness is about people, not groups. We're supposed to treat individuals fairly. And so I'm gonna specify some constraint that binds at the individual level. So maybe I want similar individuals to be treated similarly, or maybe I don't want to bias my decision making in favor of less qualified people instead of in favor of more qualified people, which maybe we're okay with. And the reason why, so both of these families of definitions have, I think, serious problems with them, and what would be really good is to find a way to unify them and get the best of both worlds. So the statistical definitions of fairness, one of the big reasons people study them is that it's easy. We can compute these statistics, we can impose these constraints, but unfortunately, none of these definitions are very meaningful. They don't promise anything to any particular individual because they're averaging over many people. So sort of I can treat you unfairly so long as I treat someone else, unfairly as well. And in fact, if you define yourself, if you know more about yourself than that you're a uniformly random orange person, then it's easy to come up with examples where these statistical definitions of fairness really mean nothing from your perspective. On the other hand, these individual notions of fairness, they're extremely meaningful. They have very satisfying semantics, but we don't except in really stylized environments where we make all sorts of assumptions, which is to say, not in the real world. We don't know how to promise these kinds of protections. And so I think where we are definitionally is that there's a lot of people studying not very meaningful definitions but that nevertheless lend themselves to ease of study. There's a few people studying, I think very meaningful definitions, but that at the moment has no direct connection to sort of computational philosophy, which by all means, I love computational philosophy, but it's not directly related to practice at the moment. And I think what's missing, and maybe the sort of definitional holy grail, is some way of thinking about things that can get some of the best of both worlds. I forget what your second question was.
Yeah, thank you. So then the more technical question. So about privacy. So DP is about you're randomizing the outcome. So, but in many cases, especially I saw that thing, and actually we have a paper on. Previous presentation. Like privacy in elections, for example. So, if you apply voting with elections, you cannot randomize the outcome. So, right. So then, you do not really have. You can just apply DP over there. So there's a recent notion of distributional DP, and which is kind of saying, let's assume that Asaria has some beliefs, distributions about what the other entries in the database are. The DP is the strict worst case. So would you think that, do you feel like that's kind of a correct notion for like high-stakes social programs, social decision process, that there's no randomness allowed for the outcome, or would you rather waiting for another more better defined or whatever? So.
Yeah, I mean, you know, look, when you can't use randomness, you have to do what you can do. But maybe some background for the rest of the audience. So differential privacy, one way to state the definition informally is to say, look, I'm going to imagine that someone who's trying to learn about my data has some prior beliefs about what my data is. But I'm going to think about sort of the worst case prior beliefs they might have, rather than trying to make assumptions about what they already know about me. And then what differential privacy promises is that in the worst case over these prior beliefs, when I look at how different their posterior belief about me would be after they saw the outcome of some study in two worlds, you know, if my data was actually sort of involved in that study, and if it was not, then those posterior beliefs should be very similar. They shouldn't have any sort of additional confidence about my data because of my participation in the study, no matter what the prior was of the sort of the attacker, the person who's trying to learn about me. Okay, and it turns out that if this is the kind of guarantee that you want, it's easy to show that, you know, the only non-trivial algorithms that are going to satisfy it are going to have to employ randomness. Now, we could also, and people have talked about definitions that say, okay, forget about worst case beliefs. I'm going to make a very precise assumption about what, you know, an attacker knows about me. I'm going to assume they've got a uniform prior or something over, you know, what my data might have been. And if you make that assumption, then you can sometimes make differential privacy-like statements whenever that assumption holds without needing to use randomness. Now, the big problem with this kind of thing, the big weakness, is that it's extremely brittle, in that if your assumption was wrong, then your guarantee doesn't promise much. And in particular, these kinds of guarantees break down entirely when you start composing multiple algorithms together, because if I see the result of one computation involving your data, then, you know, my prior for the next computation is the posterior that I arrived at after seeing the first outcomes. So one of the big strengths of differential privacy is that you can build up complicated algorithms because it's compositional. You can take a bunch of differentially private subroutines and glue them together, and, you know, now you've got some complicated algorithm that would be sort of impossible to analyze directly, but you don't have to because of this compositional property. These sort of definitions that fix a prior for the adversary and don't use randomness, they sort of entirely fall apart when you try composing things. So, you know, if you're in a situation where randomness really isn't possible, then yeah, you've got to do something. But whenever you can have it, it really buys you a lot.
Hey, I'm Wesley Tanzi. I'm from Columbia. So since we're here in DC, thinking about sort of the policy implications of everything, we have maybe 50 or 48% of the country that really believes in free market capitalism and everything, and I could imagine that, for instance, with differential privacy, right, when you think about the trade-off of accuracy in a regression model, for instance, in exchange for privacy, that means that some competitor who doesn't care about privacy might have a better model, right? And since a large swath of the population is kind of ignorant of the privacy implications, they're going to perceive the less private service as being better. And so do we need to come up with some sort of way of talking to politicians and other policymakers so that they can understand, and what is the role that government has to play in order to, like, make all of this kind of a jumbled up question?
Yeah, that's a good question, and I like it. So I sometimes pretend to be an economist in my spare time. So by the way, like, yeah, so initially, you know, it's natural to have this intuition that since privacy protections don't come for free, if I add privacy protections to my model, then it's going to be less good than my competitors, and so everyone will flock to them, and in equilibrium, we won't have privacy protections. But that's not necessarily true if people value privacy, and that's maybe an open question. But it's true that fixing, a data set, that you're going to be able to train a more accurate model, sort of with, if you have fewer privacy protections. But models also get more accurate as I gather more data. Okay, and so another way to think about privacy protections is not as making models worse, but you can always sort of, for any learning task, achieve the same level of accuracy with privacy as you would have without privacy. You just need a little bit more data. So you can write down little economic models in which people care about privacy, in which the sort of optimal strategy, the thing you want to do at equilibrium, is to actually have serious privacy protections in order to recruit users, in the sense that, if users have some cost for privacy violations, then adding privacy protections makes it sort of cheaper for them to use your service, to provide you with their data. So
that presumes that people care about privacy.
It presumes that people care about privacy. By the way, if it's truly the case that people do not care about privacy, then hey, maybe we shouldn't be legislating privacy into existence.
Well, that's why we have a representative.
Sure. So there have been, a number of studies that sort of suggest that people seem to care about privacy maybe less than they should. They'll give away sort of, arbitrary amounts of their data in exchange for a chocolate bar. But my interpretation of a lot of these studies is not that people don't care about their privacy, but rather that they don't understand the implications of having their data be used. And so this is a serious issue, but my hope would be that as some of the sort of implications, the privacy implications of data use become more clear, and I think it's starting to happen. Privacy has sort of reached the national attention in popular media. The calculus will change. Right? Apple adopted differential privacy. If you have an iPhone, data from your iPhone is collected subject to differential privacy protections. Nobody mandated that they do that, but they seem to feel that, that this is, useful brand identity for them, that Apple especially, and is positioning themselves relative, especially to Google, as a company that isn't trying to make a dollar off of your personal data. And I think that's been in part successful for them. So I would hope that that kind of thing will happen more, and so definitely in certain areas, medical data, financial data, regulation is probably necessary and a good thing. My hope would be that sort of the natural equilibrium we end up in will not be entirely devoid of privacy, and that sort of if people care about privacy, market forces will lead to adoption of privacy protecting technologies.
So let's take one more and then quit.
Hi, I'm Michael Hay from Colgate University. And so it seems like privacy and fairness are sort of two human values that the kind of computer science community has latched onto and thought really long and hard about, especially privacy and more so fairness now. So I guess I have a two-part question. So since this is a visioning session, what is the next human value that computer science should be thinking about? And then as we sort of start adding on these additional parameters to our computing systems, how do we think about the sort of composition of these sort of different values? We want something that is both private and fair, or private and fair and sort of supportive of democratic processes, or whatever. How do we think sort of from a technical level, if we have sort of multiple definitions we want to satisfy, maybe they can't be satisfied simultaneously?
Yeah. So I mean, I don't know what are the next human, I don't know, greed, lust. So I will say that there's a community organized around these things, and sort of name of what's become the flagship conference is FAT, so and maybe sometimes FATE. So fairness, we talked about that one, but accountability and transparency and interpretability is another thing people often think about. Now, I think even more than fairness, nobody really knows or agrees on what these words even mean. A lot of these, once you start moving into these other letters, often the sort of papers are empirical, heuristic. They don't have formal definitions, which is, I think, a great opportunity. Yeah, I don't know. What are the other things we should study? In terms of thinking about how these different desiderata can coexist together, I think that's a great research agenda. And to the extent that I don't think we really understand what are the trade-offs, if there are any, between privacy and fairness. And it would be great to understand if there are settings in which if we want to be private, we have to settle for something that's less fair. I don't know of natural examples like that, but if there were, I think they'd be really illuminating.
So this is a perfect thing to pull together a group of people for a visioning workshop. Okay? So with that, oops.
I was going to say, here's a candidate.
Wait, Greg, microphone. Greg Morissette, Cornell.
A candidate would be truth,
Justice.
information integrity. How do you know something you're reading is true? And what would a technical definition of true mean?
Yeah, so you want to solve fake news.
Yeah.
Yeah, it's a good one.
Okay, well let's thank Aaron for